To solve these questions, we can represent a light bulb by a simple resistor, and the idea is the same because there will be a voltage drop across a resistor, which is what happens when we connect a light bulb in the circuit. And in this case here, as given in the questions, the drop across the light bulb is 12 volt, and the power emitted by the light bulb, or the power consumed by the light bulb, is 2 watt. Alright, and when we connect a series of resistors together, let's say we have n resistor, then the total voltage drop across the 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 chain of the resistor is going to be n multiplied by the voltage drop across a single resistor. And so in part A, number one, by applying a voltage of 240 volts, we need to find the total number of lamps that we put into the series. So n is simply equals to 240 divided by 12, and this would be equals to 20. Okay, and then we need to find the current in each lamp. So to do this, we apply another formula, which is P equals to IV, and I is the current that flows in the lamp, and V is the voltage drop across the lamp. So, and then here we have the information of V and P. So we just substitute the value. 2 equals to I multiplied by 12. So it's very straightforward that I is equals to 1/6 ampere. Alright, and then for part 3, we need to find the total resistance of the lamps connected in series. So to solve this, we introduce another equation, which is V equals to IR, where R is the resistance and I is the current, which we just calculated. So, and it's given in the questions that V is equals to 240 volts, and then I, we can just make use of the answer of part 2, and then R is what we want to calculate. So R is nothing more than 6 multiplied by 240 volts, and this is equals to 1440 ohm. Alright, and let's look at part B. So in part B, it says that the filament in one of the lamps burns out, and the only replacement lamp available is marked with 6 volt and 2 watt. So this is the new lamp that we have, and let's label this as the second case. And then in the first case, we have 12 volt and 2 watt. So let's put them down side by side. So this is 12 volt with 2 watt of power. Alright. So in this case here, we need to compare the resistance of the replacement lamp and the resistance of the original lamp, where they are operating at normal brightness. So when we say that it's operating at normal brightness, it means that they are both operating at 2 watt. So, and the equation that we need to use is P1 equals to V1 squared divided by R1, and P2 is equals to V2 squared divided by R2. And R1 is simply the resistance of the first light bulb, and R2 is the resistance of the second light bulb. So since it's given that P1 equals to 2 watt and P2 is also equals to 2 watt, so we can put these two equations together, which relates V1 R1 and V2 R2 together. Alright, so since we are interested in knowing their relationship. So R2 is simply equals to well, we need to rearrange their position. It is equals to R1 multiplied by V2 over V1 square. So then we know that V2 is equals to 6 volt and V1 is equals to 12 volt. So V2 divided by V1 is going to give us half, and half square is equals to 1/4. So this is just equals to 1/4 of R1. So to calculate the numerical answer for R1 and R2, we applied this information here. We applied this information here into this equation. So P1 is equals to 2 watt, and then V1 is equals to 12 volt. And then this is what we want to find, R1, and then R1 is equals to 12 square, which is 144 divided by 2, and this is equals to 72 ohm, right? And R2 is equals to 1/4 of this value, so 72 divided by 4 is equals to 18 ohm. Alright, so part B, second questions. The replacement lamp is connected into the circuit instead of the burn out lamp, and all the lamps glow. State and explain whether the remaining 12 volt 2 watt lamps will be brighter, normal brightness, or dimmer. So the key idea to solve this question is that when we put in the replacement lamp, whether we are going to get a larger current flow through the old lamp. And the equations that we need to consider is P equals to I square R. Simply because the resistance of the original lamp is not going to change, and the only things that that's going to influence the power output of the lamps is going to be the current. So, and we know that the supply voltage is going always remain the same, which is 240 volt, right? So, and in order to know whether the current is going to be larger or smaller, we need to know whether the new total resistance is going to be larger or smaller. So initially we have 1440 ohm, which is the result that we get from part A, question 3. And then in the second case, the new resistance is equals to 1440 ohm minus 78 72 ohm, simply because we take out the burn out lamp, and then we put in the replacement lamp, which going to add another 18 ohm into the circuit. And apparently the answer is going to be smaller, which turns out to be 1386 ohm. And then we know that the new resistance is smaller than the initial resistance, so let's call this R prime T. So R prime T is smaller than R prime, right? And since we know that V T is equals to IRT, right? And then it's also equals to I prime RT prime. So what I mean by prime is that for the second case where I put in the replacement lamp, I mark it with prime. So prime should be understood as the new current value. So since VT is going to be the same for both cases, and RT prime is smaller than R prime, is smaller than RT, then the conclusion that we can make is that I prime is going to be larger than I. So, and then we apply this formula in, and the new power that we get, which is given by P prime equals to I prime square multiplied by R. And in this case here, the R is just the resistance of a single lamp. It's going to be larger than I square R, which is equals to P. So P prime is larger than P, and therefore the answer is going to be brighter.